decided some epic adventure music would just be cooler this week. So why not? Are we not embarking on a great journey, a great adventure to vanquish the semester exam? I think so. All right. So, good morning, everybody. As soon as I figure out the whole class gamification thing, and when we can make it like an actual adventure with experience points and boss fights, I will definitely do that one day. One day. But for now, we'll just have to settle for the music. Anyways, welcome to Review Week, Day 1. Before we dive into the actual mathematical questions, let me go over everything that is happening this week and next week. Your exam itself next week, that time slot is on the master schedule for my class. So you can just go there to find when our class's exam is, and of course your other periods will slot in before and after that. The review that we're working on this week, you should have already done half the problems this weekend. That was worth like 50 points, and then finishing the other half of it by Wednesday is worth another 50 points. Okay, huge homework level points designed specifically to help you overcome, if you're missing a couple homeworks, we're just going to drown those out with the sheer volume of massive points from this review. Okay. If you're missing a lot of late work, though, you still would benefit from getting as many of those in as you can. All of that needs to be in before Friday, okay? End of Friday. Friday, 11:59 is the final time to get in any and all missing or late assignments, okay? That covers homework and classwork assignments. Specifically for the classwork category, the extra credit essay would also fall into that group. That is due Friday, okay? And that is worth purely extra credit, so no matter how you do on that, any points you earn there is above and beyond what you already have, okay? You can't lose any points for that. And then over this weekend, I would advise you to spend that time working on the quizzes, okay? All of those codes are up and open and available for retake. I only recently updated your grades like last week. I have to run through and do another update here shortly. But any of those, retake them to get 100%. That's free points sitting right there. Similarly, the quest, okay? The quizzes test that you have this Wednesday. Okay, so we're going to review today, tomorrow, quest on Wednesday. You'll take it once during this time slot, and then it will also be open, just like any other quiz, for retake, and that and other quizzes will be available through the weekend up until Monday to retake. The quest, though, is worth test level points, which is 4 times as powerful as quiz points, okay? So definitely get that one to 100%. It's free stuff. Why would you just leave it there, okay? All right. That covers my list. Any questions on that stuff, logistics, quizzes, tests, what's happening, end of the semester things? No? All right, then let us grow into greatness today with our review. Here it is. And you have now posted today, I added on to the end here somewhere, the answers. There you have it. It is posted on Google Classroom, freely available for you to peruse at your leisure. Check your work as you go. But if this is not enough, if you need the full explanation, the walkthrough for anything, you let me know here and now. I'd be happy to help you out. So that said, what is it, if anything, do you want to know? If you don't have any questions now, that's fine. Continue to use this class time to work on additional review questions. Maybe you'll run into something, especially if you haven't had the chance to check it over yet. And as for anybody watching back on the YouTube playback, just feel free to hit the fast forward button, spam that right arrow until you see my screen change. When the screen suddenly changes, then you know I have started answering a question, and you can go back and play it from there. Connections problems. Gotcha. Not a problem. I will fix that. Well, the attendance, not the connection problem. I can't actually fix that from here. How cool would that be if I could, though? Just mind powers and fix the internet. How do you do number 5? Question is, which number 5? There's a lot of 5s. The first 5, symbol for perpendicular. Well, it says quadrilateral post. Circumcised. Okay. Quadrilateral post. Number 5. Quadrilateral post. Oh, this guy. Yeah, okay. That looks much more tricksy. All right. Quadrilateral post is circumscribed about. So, right? Circumscribed means around the circle. Circle Y. OR is 13. O to R is 13 inches, so we know that's that 13. S to T is 12 inches. S to T, this whole thing here is 12. Find the perimeter of post. Ooh. Perimeter. Okay, we want the distance all the way around. All right, so we're going to have to make judicious use of our congruency symbols here. And what we know about tangent lines and such because we should know that, let's take AORY. I apologize that it's so blurry when I zoom in here. Let me see if I can make that a little more tolerable. Okay. Imagine, if you will, this quadrilateral composed of these two tangent segments and the radius to, I'll just draw it in anyways, right over top of y. Okay, we know the radii are congruent to each other. I'm going to have to use 3 tick marks because 1 and 2 are already taken. So you know those are congruent. We know a radius is always perpendicular to the tangent line. So you know those are congruent right angles. Okay? And we've established prior that that is enough to conclude that this has to be a kite. And we know that a kite has not only this pair of congruent sides, but also this pair of congruent sides. So the fact that I can create a kite from any of these 4 angles of quadrilateral post means I can conclude that any adjacent segment on either side of those angles is congruent. So AO is congruent to OR. AP is congruent to CP. And those all have 1 tick line, so it means they're all 13 inches. Similarly, down here, these are all the same because I could also draw in a kite. For example, C, T, D, Y. Okay, would be a kite. Right? With me on that so far? So in general, whenever you have one of these situations, you're like, I'm not sure where to go. I'm like, find the perimeter of the, I barely got enough information as it is. Well, barely is better than nothing, okay? When you're faced with a seemingly impossible geometry scenario, start filling in everything. Anything goes. Who knows what's useful yet? Just pour all the information you can. This is where the diagram becomes really useful because it groups it all in a way that makes sense. Much better if you were to like jot down a list. I know AO is congruent to OR. It'd be very hard to keep track. So make use of the diagram here. Fill in things you know. I know this has to be a right angle with that. I know this is congruent to that, right? Eventually you'll find something like, hey, wait, that's a kite. Oh, these match. And that matches this, and this must match that. I got all these 13s here. I'm going to have all these. The only deal is I know this whole thing is 12. But thankfully from the given marks and the kiteness, I know that this half is congruent to that half, so they are in fact equal halves, each half being 6. That's a 6, that's a 6, that must be a 6, that must be a 6, and now we can add up 4 13s plus 4 6s, right? Add that all together to get the perimeter, which should be somewhere down in the answer slot. Get to the circle sections. Which number 5 is it? No, that's the solids. I didn't have sections for all these. I probably should have. I just put them down in order. Need a better context clue here. Ray K. This is a set of 1, 2, 3, 4, 5 before the 3, 4, 5. Okay. Yeah, it should be that one. I scrolled right past it. 76. Next question, can you do number 4 below number 5, the one you did for the post question? Okay, the 4 underneath quadrilateral post. So below that, number 4. This guy right there. Ah ha ha ha. All right, we have the classic problem of you need to draw more lines. I'm going to draw in a single segment here, and it's going to instantly make this question way easier. Watch this. Bing, there, done. Draw a radius. If you've got a circle, and several things to highlight here of why you should have guessed. Draw a radius, it might be helpful. A, I've got a circle. B, I've got a circle without a strict radius. This is a segment, if you stop it there, it's a radius, but I don't have just the radius by itself. It'd be nice if I had one. B, I've got a point there, and I've got this point here highlighted. Like they put an extra big dot to say, hey, this tangent line hits the circle right there. And there's a big dot there in the center of the circle. Like your toddler instinct should kick in here, like, ooh, connect the dots, right? Right there. And we know since that is a tangent line, this radius to the tangent is automatically perpendicular. So now I have also drawn in a triangle. Guess what kind of triangle? A right triangle. So, keep going with it. Triangle sum says all 3 angles of a triangle must add to 180 degrees. One of them is already 90, so the other 2 have to fill the other 90. This much is 40. So now I can find this angle right here. Must be 90 minus 40, aka 50 degrees. And that 50 degrees, again, let's highlight that point that they didn't yet, is a central angle, which means the central angle is equal in measure to its intercepted arc, h. So h must be also 50 degrees. The power of drawing more lines. There you are. Number 3 below the post question. So this guy right here? The one next door to the one I just did? Yeah, okay. All right, then let's have a look. This guy says find C. C is this arc here. Ooh, okay, I don't have a lot to go on, right? This arc doesn't have a central angle attached to it. I've got almost a, ooh, this 95 is this. It's a 95, so it's not quite the half the circle. Oh, but I have the 120 here, right? Look at this. I've got 120 here. So notice how, I don't like that. This inscribed angle intercepts this arc, right? And we know the inscribed angle is always half of the intercepted arc. So that means that that 95 degrees is equal to that arc which is C and the 120, divided by 2. So now we've set up a simple algebra equation. Solve for C, multiply both sides by 2. 95 doubled, 90 doubled would be 180. 5 more doubled is 10 more than that. So 180 plus 10, 190. 190 degrees equals C plus 120. Subtract 120 from both sides, and you get C is equal to, the 100s cancel, 90 minus 20 leaves 70 degrees. There you are. All the questions you just did, it says use the circumference conjecture to solve 1 through 12. These guys, can you do number 4? All right, number 4. If the diameter is 5.5, find C. Okay, well, we're going to use our context clues here. Circumference conjecture. I think they're talking about the circumference of a circle, often abbreviated with C. We know that conjecture is just the fancy word for the formula for finding the circumference of a circle, aka 2 pi r. We know the diameter is 5.5, so we need to find r. Good thing that diameter equals 2r. Oh, hey, wait, so the circumference is also diameter times pi. So the circumference in this case equals 5.5 times, leave your answer in terms of pi. No 3.14 here. 5.5 pi meters. Really? That's it? Yeah, that's it. Should I put a box around it? Call it done? There you go. The more you can go back and forth between these two versions, quick and easy, using whichever one is more convenient for you, the more time you'll be able to save. Can you do number 5 below the circumference conjecture? By below circumference conjecture, do you mean the next one still under those directions or on to the next page? Next. Okay, good. Let's say if I just did that and then like this one is the exact same thing. All right. Number 5 here. The radius is 18 feet. Okay. That's nice to know. Can we get that like on the diagram somewhere? Just follow radius. 18 feet. There we go. The length of arc RT is what? That's what we're wanting. Okay. Length of an arc depends on 2 things. You need the measure of the arc and the circumference of the circle. So first start with measure of the arc. How many degrees of arc is this? Well, it's intercepted by an inscribed angle. This is on the edge of the circle, not the center. So the inscribed angle is half of the arc, which means RT, the arc is double that. That's a 30 degrees in there, so that makes this guy 60 degrees. Okay, so the length of arc RT here is going to be 60 out of 360 times the circumference of the circle, which, as we just discussed, is 2 pi r. And so stick the pi there, 2 there, and the radius of 18. Now all you have to do is simplify that. Let's double check the directions. Did they mention leave it in terms of pi? They did not, so let's include both. Okay. So let's see, some quick math here. We can use the zeros. 36 is divisible by 6. It's 6, so we have 1/6 there. And, 18 is divisible by 6. Remember, all this stuff is just getting multiplied, or does it matter here? 18 divided by 6 is 3. So that means this is equal to pi times 2 times 3, which is just 6 pi, or approximately 6 times, I've got my calculator handy here. Let's get the result, 6 pi, 18.850. Just to give you an idea there. I usually prefer the exact form of the answer. You can double check with the key down below, whichever one. I skipped question 1 from this group, so I didn't grab the directions that would have specified that. Number 3 and 4, where you did number 5. This same one, the last one? Because we've done 2 number 5s already today. Yes, okay, this last one. Okay, 3 and 4 here. All right, and that'll probably be the last ones for today, looking at the clock there. Okay, length of arc big is, okay, arc B-I-G, B to I to G. Okay, so we need all this around here. So real quick, the whole circle is 360. This arc, though, is 150 degrees, so the measure for big is 360 minus 150. So that's going to be 210 degrees around here. So now we have our arc measure. Put that into our formula for length. It's going to be your measure out of 360, so 210 out of 360 times the circumference. 2 pi r, our radius, as listed right there, is 12 centimeters. So 2 times 12 is 24 times pi. So let's just reduce this fraction here, get rid of the zeros. 21 and 36 divisible by 3, so that leaves 7 and 12. And, 24 is divisible by 12. So 24 divided by 12 leaves 2. And now I just have 2 times 7, or 14 pi. So there is length of arc big. It's a big arc. That's a lot, okay? All right. And number 4, length of arc AB is 6 pi. The radius is question mark. Ooh, it's a work backwards question. Okay, well, let's use that same setup, fill in what we know. So 6 pi should be equal to the arc measure. We're talking about arc AB, so we are given that 120 out of 360 times the circumference pi r, 2 pi r, excuse me. So the 2 and the pi we know, the r though is the unknown, so we're just going to solve this equation. Okay, good old Algebra 1 techniques here. So divide both sides by matching items, divide both sides by pi, there they go. Divide both sides by 2, that leaves 3. And now the only thing left to get rid of that r is this guy here. How do we get rid of a fraction? Being multiplied, we'll multiply by the reciprocal. So that reduces with that reduces with that. Same thing on both sides. A divided by 120. So now notice I've crossed out everything here except r. And all we have left here is 360 divided by 120 times 3. Let's see if we can quick reduce this a little bit. 36 divided by 12 is, in fact, 3 all by itself. So 3 times 3 is 9. So our radius here is 9. What are the units? Meters. There you go. And with that, we've got 3 minutes left in class. So I'm going to call the YouTube stream as done right here.